Okay. Okay. It was like a battle that I need to win by making water available in your land. Here is a silent future. Common area, that's irrigable area, is 1,500 acres. And the cost of the project is 2 million labor force, the cost of 2 million labors wage. And the main, it's benefit population, the farmers 5,000, and main canal length is 11.6 miles, and there are other 27 branch canals, both major and minors. Here is the location map. Nepal in between India and China, Tibet. It's the project area, and it's about it's less than 250 miles west of Mount Everest, the highest peak, and less than 150 miles northeast of Lumbini, the birthplace of Buddha, and it's 140 miles west of Kathmandu. Here is the index map showing the green area. Green area, I expected that if I have pointer. Green area is the common area, that's the irrigable area, and the bushes are the jungle area. The thick blue line is the main canal, and thin blue lines are the major branch canals. And here is the location of the office. This is the source stream, the dream of 5,000 villagers. We can see the steep slope, and what that one has to walk. I spent 3 years walking through this area. This photograph was snapped around 2.5 miles downstream from the Hedrock side, from where we need to trap the water for irrigation. And here is the structure, the side intake to trap the stream water for irrigation. We provided screen. These are the screens, and these are to prevent the borders and cables from entering into the main canal. However, they need to be separated before entering into the main canal. And this is done with the help of this settling basin. With the increase in the flow area, there will be decrease in the flow velocity for the constant discharge, and thus making the sediments settle down. And they are removed with this help of this cross regulator, and make flow back to the stream to the through the skip channel, and the clean water will go for this canal regulator. The sea level of this canal regulator is higher than the bed level of the cross regulator. And here is the bird's eye view showing main canal and escape channel, about which we just talked about, coming from the settling basin and joining the stream. And this is the stream. And all these structures need to be protected during the high flood period. And this is done with this help of this earthen embankment, blanketed with crated boulders and launching apron. And still we can see the side here. Here is the main canal following the mountain part. We need to follow the part of the mountain, and at the same time we need to make the main canal according to our requirements. One is canal size for the required discharge. The second one, the canal slope for the required velocity. Velocity plays some role in the canal discharge to some extent, but they need to be within some limits, because most of the canals are earthen. They are not lined, and they flow under gravity. The beginning part was not the easy one. One is bigger in size. The canal size is bigger. The second one is we have very limited rooms to change the alignment, to shape the alignments. So we need to hit the iron when it's hard. And still we can see the canal regulator that is attached with that settling basin. And all these canals, main canal, branch canals, are designed by using the Manning's formula. That Manning actually did not like that formula, but still we are using right now. That was more than 100 years ago he developed. And mineral is the main canal characteristics in the mountainous area. Apart from making the main canal and branch canals, we need to make many structures, make different type of structures before making water available in farmers' land. There are two challenging structures in my project. They will cross bridges for siphon pipe. The construction of these two cross bridges shortened the canal length by 2.5 miles, two big loops in the jungle area. That made very extensively easy during the canal operation. But here it is, we made it. But the beginning part, construction part was not easy. Every part of the cross bridge need to be carried out by human beings on their back for 16 miles. And cable method was the only one that I can start construction of the cross bridge. With the help of cable, this is the cable. With the help of cable, we were able to hang hangers, and with the help of hangers, we were able to use the planks and thus started the construction work. And here it is. This is the first cross bridge located at 8 miles from the source and seems to be flying. And it's 100 feet above the base stream. And here is the second photograph of the same cross bridge, showing the cross bridge and downstream siphon pipe. Here is the second cross bridge, located at 2 miles downstream from the first one. That means 10 miles from the railroad side. And here is the second photograph of the second cross bridge. Apart from cross bridge, we need to make many other structures, as I mentioned before. Aqueduct for canal water over drainage water, and superfices for drainage water over canal water, and footbridges for crossing men and animals, and many other structures we need to construct on this way. And this is the photograph during the time when we were constructing one aqueduct. And here is the completed portion of the aqueduct. It's the longest one, and its total length is 112 feet long. And sometimes we need to drain the water out of the canal completely. This is done with the help of skip gear. And all the regulators, skip gears, they are manually operated. And wherever possible, I used to provide an automatic spillway. With the rise in water level after certain depth, flow out of this canal and joins the drain. And our main command area was at lower level than the railroad side. And it should be, otherwise water won't flow under gravity. But it's much lower than the slope we provided in the canal. So the difference is adjusted by providing the slopes, and it was in the main canal. When slope is steep, we provided series of falls, and we said just it. And this in a small branch canal. And here is a small fall structure, almost at the tail end, about 11 miles from the yellow side, and we can see still water running out of this. Our main objective of the construction of these structures, main canal structures, was to get the stream water in the farmer's land. This was done with the help of main canal and branch canal. And water distribution is done with this help of canal regulator. Sometimes we have to use planks on the downstream side of the groves on the downstream side, and to raise the water level if the water level is low.
The picture went off.
So thanks for